Hey, welcome back to another video lecture for calculus. The video is designed to support a calculus course that I'm teaching this semester. And in this video, we're going to look at just several examples of the product rule, and I've written the product rule on the board. If you haven't watched that video, you need to go back and watch that before you do this, or this will make absolutely no sense. So the product rule says that when you have two different functions of x that are being multiplied together, we follow this kind of special formula for it. I've shortened it so that those functions are named u and v. So you take the first one and you write down the derivative of the second one, and then you add the second one and you write down the derivative of the first one. The way this is said out loud, again, it's 1d2 plus 2d1. And I wanted to show just a couple of quick examples with that so that you have a really good idea of how this works. And in some of these examples, there's some tricky things that can happen. Some of them are easy to do with the product rule. Some of them, there might be a trick that helps you do this a simpler way. So I wanted to show that just in case, so that you have a pretty good idea of when you can simplify something and when you need to just go ahead and do the product rule to find your answer. So the first example we're going to work through is a pretty simple one. It's going to be x to the fourth power times e to the power x. And what we want to do here is to take this expression's derivative. So here with the product rule, what I like to do is identify the different parts of this expression. And by parts, I mean which functions of x do we see. Well, we have an x to the fourth, and we have an e to the x. So if you want to plug this into the formula, we could call the green part our u, and we could call this pink part our v. And we just follow what the formula tells us to do to write down the answer. So the first thing it tells us to do is just write down what u is. Well, that's x to the fourth. Then it says to take the derivative of v. And if you haven't watched the supplemental video for what the derivative of e to the x is, you should probably go back and do that. But that derivative is just e to the power x. So then it says to add the second expression. The second expression is just e to the x times the derivative of the first expression. And the first expression is x to the fourth, so we apply our general power rule. At this point, we know the power drops down, and the new power is one less. And if we wanted to try to clean this thing up, we could, but what we have is a working derivative, so this is our answer. Another way you'll commonly see this with e to the power x is you will actually get e to the power x and then x to the fourth plus 4x to the third. And there was a small thing I wanted to show you here because it may actually be easier if you can recognize that this is how every single one of these derivatives works. When you have e to the x times just some polynomial, there's actually a formula you can use for that. So suppose that you have some polynomial that's x to the power n, and then you have it multiplied by an e to the x term. The power rule says, product rule, says write down the first function, take the derivative of the second function, which is just e to the x, write down the second function, which again is just e to the x, times the derivative of the first function, which of course you see is just our general power rule. But notice every time that we plug it doesn't matter what polynomial I plug in for this x to the power n, it could be like 2x to the n, 5x to the n, 7x to the n, whatever. What you can do is notice that you always end with this situation where you have two terms that are combined in a linear fashion. That is, they're separated with a plus or a minus sign. And so you can always factor that e to the x out in front of it. And then the formula goes, just write down x to the power n plus the derivative of x to the power n. And so you get something that looks like this. Well, notice here, if this guy is u and this guy is v, then the simplified version of the product rule for anything that is e to the x times a polynomial will always be e to the power x times that polynomial plus the derivative of that polynomial, and this is a formula that you can use to simplify the product rule in any case that looks like this, and we may see some more examples like this going forward. Okay, so I'll clear the board and put the second example up, and we'll keep on moving. So the simplified version, e to the x times u, where u is some function of x, is e to the power x, u plus u prime, and that is it. Our second example that we're going to do is going to be x times e to the power minus x. And so what you need to know about the derivative of e to the negative x is that it actually is not just e to the negative x, it is going to be negative e to the power negative x because of the chain rule, which will be discussed in a later video. But just notice with this sort of thing, this is not just e to the x times some polynomial, so we're not going to use our simplified formula, although we can derive another simplified formula when we have this sort of case here. In this case, we're just going to apply the power rule, knowing that the derivative of e to the negative x is negative e to the power negative x. So the product rule says write down the first function, and again what I need to do is decide what my functions are. I have this function of x, which I can call u, and I have this function of x, which I can call v. So it says to write down the first function, u, which is just x, times the derivative of v. Well, that's negative e to the negative x, so I'll put the negative symbol out in front of it and then write down e to the negative x because those two things are being multiplied together. Then it says add the second function, e to the negative x, times the derivative of the first function. Well, notice the first function's derivative is just 1, so this thing here is my answer, and I'm done. Again, you notice that we have an e to the negative x term that drops out of this, so you can kind of figure out that there's a factorization that happens here. And if you want to derive a simplified formula for it, I would suggest that you try that. Notice you got to be careful of the negative right here. If we factor out this e to the negative x, then there's going to be a small sign change that happens there. So just make sure that you're doing that derivation correctly if you want to try that, but I think it's a great exercise. For our next example, we're going to look at another e to the x situation, although the variables are going to be a little bit different. We're going to do e to the power p times p plus p square roots of p. And there's an interesting situation here because if you notice, we have this function of x here, function of p, I guess, this we could call u, and we have this function of p here, which we could call v. Should do that in a different color. We call that v. But furthermore, if you look very, very carefully at this thing, inside of the parentheses, I have this p times square root of p business here. And so you have a choice on how you want to do this. Some people just like doing the process of the product rule over and over. When you try to take the derivative of v, if you do not simplify this yellow and blue term here, then you'll have a second product rule that has to be applied. Some people don't like the nested product rule situation because they lose track of where they're at. I do want to show a very quick way that you can kind of do that process with a nested product rule and not lose track of where you are. So this is pretty common in product rules because we know that what happens is you get 4 different terms and they're paired off and multiplied together, and then there's a plus in the middle. So the product rule says you're going to get something times something else plus something times something else. And we know that the problem is when we try to find the derivative of v, that would be this one right here, is where the v prime is in our formula, then there's an extra thing happening if you do not know how this simplification works. So we know that that one's going to be difficult to figure out, but the others are not. So what I can do is I can just go through the formula and write down the parts that I know, which is this parenthesis, and this parenthesis. then I can worry about what this one has to be. So the u part, the first parenthesis, is just e to the power p. Okay? The v part is just all of this stuff underlined in pink, and that's this third parenthesis right here. So I'm just going to write it down. Then we also know that the derivative of the u part is really, really easy. That's this last parenthesis here, because the derivative of e to the power p is just e to the power p. So really where I'm going to have problems is just that second parenthesis. Well, now what I can do is I can just calculate what this has to be. And what you'll notice is that you have the linear combination of two things here. So since derivatives are linear, when I'm trying to find out what this derivative is, I can just say, what's the derivative of p? Well, it's 1 plus, and then what's the derivative of this thing? So p times square root of p. You have a choice. You can either recognize that that's p times square root of p, two functions of p being multiplied together, and therefore a second product rule. You can do that. Or you can recognize that this is p to the first power times p to the 1/2 power. And when you multiply things that are in the same base to a different exponent together, you add the exponents. That's a college algebra rule. So this is actually the same thing, and I will write that down here. The other way to write this would be p to the 3/2 power, and of course in one of the 1.3 extension videos we know that the general power rule applies to this as well. So the derivative of that part right there will be 3/2 p to the 1/2 power. And this great big ugly thing, well, that's your derivative. That's it. If you want to try to simplify it, you can. I don't recommend it. I mean, you could notice here that you have an e to the p in both terms, so you could like factor that out and then combine all this stuff together in a linear fashion. But it's not going to get much prettier if you do that, so I would just leave this. This is your derivative, and you are done. It's functional. We can start plugging stuff in if we were required to. Okay. Next example, again, has e to the power x in it, is going to be x to the third power plus 2x all times e to the power x, and we are trying to find this thing's derivative. So again, notice that we have this this nice polynomial situation, and I'll leave this as an exercise for you to figure out, but you can actually use the simplified formula for this. It's just there's an extra little step in there, because notice that this formula only accounts for one function of x, and they're not being like linearly combined, but you can work out what that has to be if you wanted to. Otherwise, we can just apply the power rule. Power rule says write down the first function, and here we're going to define our first function to be this x to the third plus 2x part, and our second function to be this e to the power x part. So the product rule says write down u, write down the derivative of v, derivative of v is just e to the x, plus write down v, e to the x, times the derivative of u. And since that's a polynomial, at this point we know we just go through it part by part, and we use the general power rule. We will get 3x squared plus 2, and this big honkin' thing is our final answer. Now again, you could like factor in e to the x out and then combine some like terms and stuff, and I'm going to go ahead and do that because this one is actually a little bit prettier if you do that. If you factor out the e to the x, well then you have this thing plus this thing, which is x to the third power plus 3x squared plus 2x plus 2. So we get a nice big long cubic polynomial times e to the x, and that thing is our cleaned up answer. Some people don't see much of a difference between this and that, so it's just a matter of if you see the simplification and can do it, go ahead and do it. If you don't like the simplification, you can leave it like that, because again, it is a functional derivative we could plug things into and get answers out of. Notice every time it's just write down the first, derivative of the second, plus write down the second, derivative of the first. Done. Last example I'm going to show is this. We're going to have u minus square root of u times u plus square root of u. And again, we are trying to find this thing's derivative. Now, here we do have a product rule, but notice that if I do the product rule here, there's not really any term that's necessarily easy to take the derivative of. And by easy, I mean it's just like an application of the general power rule with no funny business attached to it. So because I have these square root symbols, I know that I'm going to end up having to do a rational power sort of power rule with it, and those have a tendency to produce some kind of nasty answers. So what I like to do for these is, if you have a situation that you can easily recognize, notice here, this is like our u, and this is like our v, but they are conjugates of each other, and so this is a difference of two squares, which means that we can write this thing as u squared minus the square of square root of u, which is just u. So although there is a way to get the answer to this with the product rule, the point of putting this example into a product rule video is don't just say, oh, it's product rule, and then jam it through the rule. Try to find some of these nice algebraic structures that we know about, like difference of squares, difference of cubes, because it can make your life significantly easier. In this case, we have a polynomial, and so the derivative of this thing is extremely easy. It's just 2u minus 1, boom, we're done, and we can move on. If you don't recognize that that is the case, well, then we're going to have to do this nasty derivative and that nasty derivative, and you notice that's a little harder than just saying, well, what is that thing's derivative? Furthermore, I should probably say that's d du. U as a variable in this case, not a function of x, and so this is what we end up with. It's a little bit different if we make it a function, but that's a kind of subtlety there that I left out to begin with. Just note in this case u is actually a variable, not u in the sense of our rules over here. Okay. So again, product rule, just remember 1d2 plus 2d1. Try to look for things that make your life easier. There are plenty of things that are written in terms of the quotient rule or the product rule that there is a simplification for that will make it something easier. And again, if you have slept since college algebra, a suggestion, make sure you know that when you have two things that are conjugates to each other like this, two binomials which are conjugates of each other, then that is a difference of squares, and a lot of times that's going to simplify your life greatly.